This is X4, questions 1 to 3 that are related to search and BFS DFS. So the first question is not really related to anything. So it's just a puzzle that we played during the lecture. So we did like the 16 or the 15 puzzle. And here is a very small version where you have a board with 3 tiles, 1, 3, and 2. And there's an empty space. And you can move them around, and you can move the 3 down, or you can move the 2 to the right. And then after 2 is moved to the right, you can move 1 and so on. So if you try to kind of visualize this, you can see that no matter how you move them around, if you write down the numbers clockwise, which means like this, then you will always get 1, 3, and 2. So maybe you should try to convince yourself that no matter how you move, it's impossible to get to a configuration where if you write down the numbers clockwise, it becomes 1, 2, and 3. So knowing that, we just write down all the numbers starting from 1 clockwise. If it's 1, 3, 2, then we're okay. If it's not, then it's impossible. So the first one is actually 1, 3, and 2. So the first one is okay. And the second one is 1, 2, 3. So again, starting from 1, just write the thing clockwise. If you want to do counterclockwise, you can do it, but do these things consistently. So in particular, that's not going to work. We can never reach that state. And similarly here, that's 1, 2, and 3, so not going to work. Here is 1, 3, 2 again, so that's going to work. The question is, which ones can reach the goal state? So yes, I'm checking off the correct one. And again, that one is different, so it's starting from 1 and do clockwise. So that's a bit different, but 1, 3, 2 as well, so that's reachable as well. And note that this specific trick only works for the 3 puzzle version, but there is actually generalization of this idea of the permutation, how to figure out which kind of 8 puzzles can be solved, but I'm not going to talk about it here. And you are not supposed to know that for the purpose of the exam, but if you're interested, you can look up online like how to figure out the permutations that are possible for 8 puzzle and 15 puzzle. Okay, in any case, let's move on to the next one. I did this in the lecture, so I'm going to go through this quickly. So the trick here is if the successors are 2i and 2i plus 1, then when you draw the tree, it's basically all the integers. So what I mean by that is if you draw 1 and then the successor will be 2 and 3, which means it's 2 times 1 and 2 times 1 plus 1, and the successor for 2 is 4 and 5, 6 and 7. So you will notice that we're kind of lucky in a way that the next one is 8 right after 7. So if you change this slightly, like 3i and 3i plus 1, that will no longer work. We cannot fill in like everything. So it means if we end at 7 here, we may jump to some larger number in the next layer or next level actually in a tree. It's not called a layer. In any case, we can write down more to convince ourselves, and that's 16. So it happens that we end at 15 and the next one is just 16. So basically the tree covers every number possible. There are no holes in the tree. And the question is asking about BFS. So BFS is just, let's see, search the first level, search the second level, search the third level, and so on. So if we want to get to 16, we need every number between 1 and 16. So of course the answer is 16, and here we are doing until 1024. So we need every number between 1 and 1024. So that. Okay, that's just, again, we did this in the lecture, and you can just write down smaller trees and find a pattern. That's basically it. And the same thing actually happens, the tree looks exactly the same for DFS. And during the lecture, I mentioned about the convention of when we have a stack, put the larger index into the stack first. What that means is we're going to put 1, and then the successors are 2 and 3. So we're actually putting 3 first, so 2 get popped, or 2 get removed from the list first. So we are removing 1, we are removing 2, and then the successors are 4 and 5, and we are removing 4. So again, that's what I mean by putting in the larger index first. If we do the reverse, then it's actually we're removing 3 first. Then it's kind of confusing what order we're going. So I'm not going to do that. And then 5 would be, 4. If we remove 4, we're going to put in push 8 and 9, and remove 9, put in 16, and 2 times 8 plus 1, 17, and so on. So basically, if we want to do DFS and reach the goal, 2 to the power, say, 4, which is 16, we need to remove 1, 2, 3, 4, 5. We need to remove 5 of these things. And if we want 2 to the power 10, which is 1024, we probably need to remove 11. So that's the answer here, 11.